Greetings, fellows Finite students. This is Mr. Allen here, and I am going to go over the Chapter 3 in review. Now, you guys are checking this, I know, from your Chromebooks or your home computers. The purpose of this video is not to... I really don't want to go over the details. We've been through the details. You've been through the details. It's to kind of, just talk about the chapter in review, and I want to give you some tips and things as you prepare for the upcoming quiz and then eventually the test. As you know, I've said basically since the beginning of school that Chapter 3 is when things kind of get fun. We just had our quiz on Chapter 3, which you guys did pretty well on. That was sections 3.1 and 3.2. The next quiz is going to be a little bit harder, and the quiz is going to be a little bit harder too, but I'm hopeful based on what I've seen that you guys are going to do fine. So let's go ahead and get after it. Section 1 in Chapter 3, here are the key concepts that you need to know. Sample space. What is a sample space? A tree diagram. This, gosh, I mean, a sample space is important, but tree diagram is going to be very important. Not so much in this chapter, I mean it is, but really in the next chapter we're going to be using tree diagrams quite a bit, particularly when we get into something called Bayes' theorem. The fundamental counting principle, cannot emphasize enough how important that principle is. You need to know it, and I think you do, but you also need to know when to apply it in other situations. And then this thing called factorial notation. Last few times that we've met, we've done some work with the different formulas for permutations and combinations, and in order to really deal with some of those situations, whether it be simplifying or solving, you really got to understand what factorial notation is and how to manipulate it. And that's why we've been doing that work, so that you'll be comfortable with that. Section 2. A permutation. So section 2 is really called permutations. Remember, permutations is basically ways to arrange things with regard to order. However, there's a couple of different ways we can do that. The main formula that you're probably thinking of when you think of a permutation is a permutation without replacement. There's also permutations with replacement. You need to be able to distinguish between these two. They will give you very different results. So you need to determine if order is important, is there replacement or is there not replacement? Distinguishable arrangements with indistinguishable objects. So this is kind of like the Mississippi problem you guys have heard of me talking about, where you have, a word that has multiple letters and some of them are the same, and you can't really distinguish between, for example, the S's in Mississippi if you switch them. Circular permutations. This is an easy one. That's obviously why I got the graphic for this page. Circular permutation versus a regular permutation. A couple of you missed that on the quiz, so I'm hoping that you'll pick that up and recognize if you've got a circular permutation or not. Section 3. This section is on combinations. So that's the main idea, and that's combination. And by the way, the combination formula that's given here in this book is combinations without replacement. There's actually another formula for combination with replacement, but we're not going to really focus on that in this course. I don't want to give you more and just confuse you. Pascal's triangle, which is what I've got a picture of here. Pascal's triangle can be used to actually generate combinations. Unordered partition. This is when, for example, you've got a group of students, you're going to divide them evenly, and the order in which that they're placed does not matter. That would be an example of an unordered partition. It's probably the hardest to remember formula, so please make sure you review that. So, let me give you some final suggestions here before I turn you loose on your assignment there. You must decide which formulas are appropriate for a given problem. On your assignment today that I'm giving you, you are going to have to shift gears. You're going to read a problem and you're going to have to decide, okay, is it a combination? Is it a permutation? Is there replacement? Is there not replacement? Is this something weird like a circular permutation or, an indistinguishable object? You have got to make those determinations. That's really important, and that's what makes this section or this chapter so hard. is any one thing by itself is no big deal, but when you start putting them all together, that's where things get kind of tricky. If you get stuck, try creating some simpler example of the problem and see if there's a pattern. So maybe, you know, if I'm talking about picking, I don't know, I'm picking marbles out of an urn, and there's a whole bunch of marbles that are blue and some are red and some are green, and instead of dealing with, you know, large numbers, maybe make it an urn with, you know, 2 green, 1 red, and 1 blue, or something like that. Try to do something smaller. See if you can figure it out. Even maybe, you know, draw some examples of it, and then try to see if, you know, you maybe do it again and see if there's some pattern that can help you determine what's the right answer or the right way to get the answer. Be careful to determine when you have an and versus an or situation. And then there's the bad news. You could actually have an and an or situation. So I try to give you the hint of when there's an and situation, you multiply, and when there's an or situation, you add. But there are actually situations where you might have to do both within the same problem. We typically do that with combinations. If all else fails, make your best judgment and show your work. So if you get to a problem on the homework, or if you get to a problem on the quiz or the test, and you're racking your brain and you don't feel confident about the answer or how to get the answer, just reread the problem, make your best judgment, show your work, and then hope for the best. It's kind of hard to check the answers on some of these because the numbers are so large. And that's it. Have a good day, guys. Your assignment is on my big campus.